This question is from Jun2004. It's question 3A, or 3. A particle moves from rest along a straight line starting at time t equals 0 from a point x. From t equals 0 to t equals 1, the particle moves with uniform acceleration. From t equals t1 to t equals t2, the particle moves with uniform velocity. And from t equals t2 to t equals t3, the particle comes to rest with non-uniform acceleration. On figure 3.1, sketch a graph to show the way in which the velocity of the particle may depend on time t. So the first part of the graph has got a constant, uniform acceleration there, you can see, and we know on a velocity time graph that is a line of constant slope. So we'll just give it a value that it goes to there. Let's see up there about this, right? And then it says it moves with a uniform velocity between t1 and t2, which is along here. And then it comes to rest with a non-uniform acceleration. So this is not a straight line, but its velocity does decrease to 0. So we'll just draw a curve. We don't really know what shape the curve is, but we do know that it is curved down to t3. State how the total distance the particle travels from x may be determined from your graph. So this is very similar to the last question. And again, you need to say that it is the area between the line and the x-axis or the time axis. And that will get you your mark there. Part B. Two model cars A and B move towards each other from opposite ends of a parallel track, as illustrated in figure 3.2. So A is moving this direction and B is moving this direction, and there's 2,000 millimetres apart when the timing starts. Car A is then moving with a uniform velocity of 50 metres per second. 50 millimetres per second, they're model cars. And car B starts from rest when timing starts, accelerates uniformly at 4 millimetres per second for 10 seconds. So there's a point, this starts at rest but doesn't gain a constant velocity until after 10 seconds. So what the first thing the question asks you to do is calculate the distance travelled by car A in the first 10 seconds and then the distance travelled by car B. So the distance travelled by car A in the first 10 seconds, you know it's moving at a constant velocity of 50 millimetres per second. And so speed equals, we're just going to use, we don't have to use equations of motion. There's no acceleration involved. So speed is distance over time. Or maybe I should be saying velocity is displacement over time. And we're going to measure distance or calculate distance. So it's speed by time. Speed is 50 millimetres per second. Time is 10. And that gives you 500. And of course the answer is in millimetres. So we know that after 10 seconds, it has travelled at 500 millimetres, and that's 2,000, so it's approximately there. Okay, then calculate the distance travelled by car B in the first 10 seconds. It is accelerating, so we need to use our equations of motion. So we know that U is equal to 0, A is equal to 4, T is equal to 10, and we're looking for S. So we're going to use S equals ut plus a half at squared, and that's equal to 0 plus a half times 4 times 10 squared. So that gives you an answer then of 200. Part 3 of the question asks you to calculate the distance from the initial position of car A when the two cars become level. So if we have a wee look there just to see exactly what's going on there, you can see that the car A has travelled 500 metres and car B has travelled 200 metres. And so therefore the distance between them when they're travelling at constant speed is going to be 2,000, take away 500 and 200, which is 700. So there's going to be a distance between them of 1,300 metres. And that's a ratio, you have to go and split that up into a ratio of the distance that A travelled compared to B when they're meeting each other at the same time. Right, so we now know that B's travelled 200 metres, A's travelled 500. And what we're going to do first of all is to try and calculate the velocity of B here, so we know what that constant velocity is. So the velocity of B, you can see this velocity of B. We're going to use equations of motion, V equals U plus AT. And the initial velocity of B before it started off, I'm going to do it over here actually so we have more room, is going to be equal to 0. Its acceleration, you're told, is 4 millimetres per second, and the time it travels or accelerates for is 10 seconds, by 10 seconds. So that final velocity for B is 40 millimetres per second. So A is travelling at 50, B is travelling at 40 millimetres per second. Therefore, we know that when they meet each other, the time from this constant constant velocity for both of them has to be the same, the time they've taken. So if we factor that into our equation here, when cars meet, time for both is the same. Now that they're travelling at a constant velocity, we can use velocity's distance over time. So velocity of A is equal to the distance of A over the time, which is the same in each case. And therefore the time, the distance for A, or displacement for A, is going to be VA times B. VA was 50 and T is just T. It's just a time we don't know. For B then, so that's displacement of B over T. And again, the displacement of B is going to be equal to 40T this time. And now what we can do is rearrange those in the form of T and put them equal to each other. So T is equal to SA over 50. And then on this side, T is equal to SB over 40. So we're going to put those equal to each other and look at the ratio of them. So they're equal to each other. And therefore we can say that SA over SB, those are displacements again, is equal to 50 over 40. In other words, there's a ratio of 5 to 4. So SA, the distance or displacement that A has travelled has a ratio of 5 compared to 4 of the 1,300 metres. So the ratio is SA to SB is 5 to 4. So we have to split our 1,300 metres up into 9 parts and multiply by 5 to get the answer for A. So SA equals 5 times that ratio, 5/9 of 1,300. And that gives you 722 metres. And B, we don't really need to know B, but we'll do it anyway. It's 4/9 then, which is obviously 1,300 take away 722. And that comes out to be 578. But we're not quite, this is a number we're interested in because the question asks you the initial position of A, but it asks you the initial position of A from the starting point, or what's its position now compared to the starting point. So you have to add that on to the 500 metres that had travelled in the first 10 seconds of motion. And so 500 and 722 gives you an answer of 1,222 millimetres. And that's the distance here where the two cars meet. At that stage, the car B has travelled 200 plus 578 metres. So that's 778 metres. And that should be right.